Okay, so if you remember back to Algebra 2, when we solved the question like this, we would convert it from exponential form into log form. So we would write log base 7 of 5 equals x. And then we would go here in our calculator and type this in. But there's another way to solve this problem. I could solve this problem by taking the log of both sides. So it doesn't matter if I use the common log, which is log base 10, or the natural log, which is ln. So I'll use just a regular log, common log. So log of this, log of this. And I'm just logging both sides, and that's because in an equation, whatever I do to one side, I can do to the other. And as long as I'm keeping it balanced, that's okay. Then I would apply my log properties. So I would take my power and move it to the front. So this would become x times log of 7 equals log of 5. And then if I'm solving for x, I would divide both sides by log of 7. So I would get x equals log 5 over log 7. And if two things are equal to each other, if two things are equal to the same thing, they must be equal to each other. So if I wanted to test this on my calculator, I could. So I could do alpha window 5 log base 7 of 5, and there's my decimal. But I could also do log, the regular common log, 5 divided by log 7, and I get the same answer. And the same thing would be true if I had taken the ln of both sides. So I'll do it again. So if I had 7 to the x equals 5, I could ln, or natural log, both sides. Once again, as long as I'm keeping it balanced, that's allowed. So I'm going to apply my log rules again. So I have x times the natural log of 7 equals the natural log of 5. And then I'm going to divide by the natural log of 7. So I have x equals the natural log of 5 over the natural log of 7. So if I go back to my calculator, the natural log of 5 divided by the natural log of 7. And they're all the same. So this is because of the log property called the change of base formula. So the change of base property or formula is this. You're going to take your base and drop it into the denominator. You're going to take what you're taking the log of and put it in the numerator. And then as long as this is the same, the log base, it doesn't matter. So log base 7 of 5. This would be log, I can use base A, of 5 over log base A of 7. Or log of 5, which technically has a base of 10, over log base 10 of 7. Or the natural log of 5 over the natural log of 7. Or I could even do log base 3 of 5 over log base 3 of 7. As long as you're keeping the bases the same, it will always follow this rule. So this property illustrates that all logarithmic functions are actually vertical dilations of each other. So what are our relationships when outputs, with the outputs when we raise a base to a power? So let's talk about this a little bit. I'm going to apply my log properties. And I just have the change of base formula. So the base drops down. So I have log A, and I'm just going to use the common log, but if you wanted to make this something different like the natural log, that's fine. And then this comes up top. So I have log base x, log of x over log of a. I'm going to do the same thing here. my base is going to drop down. So log a squared. And I have log x in the numerator. But remember, my log properties tell me that I can take this and bring it to the front. So this is the same as log x over 2 log a. And there's an imaginary 1 up here, so I can actually pull this out and make this 1/2 of log x over log a. And now if you notice, this is this. So what actually happens is when I square my base, my output is multiplied by 1/2. So in general, the output is multiplied by the reciprocal of the exponent. So what does that mean? If I had something like log b cubed of x, it's the same as 1/3 log x over log b. And it can work in both directions as well. So let's take a look at what this means. They're telling me that log base b of 2 is equal to 54. Which remember, if you needed to write this, you don't have to, but if you needed to, this is like saying log 2 over log b equals 54. Do you want to know what's this? Well, we can use our rule with this piece that if I'm cubing the exponent, I'm going to take my output and divide it by 3 or multiply it by 1/3. But I could do it the real way if I wanted to as well. This is the shortcut in the purple. But I could do, this is log 2 over log b cubed, which becomes log 2 over 3 log b, which is 1/3 log 2 over log b, which is 1/3 times 54, which we did using our shortcut. It's totally up to you how you do this. If you do it the long way, that's fine using your log properties, or if you remember the shortcut or the rule, that's fine too. Remember, we don't have a calculator, so if you needed to, we're going old school here. 3 goes into 5 one time. So this is 18, okay? So what's happening in the next one? Well, taking this, and this is, remember, radical b is technically b to the 1/2. So that means this output, the shortcut, is going to be 2 times 6, which would give us 12. But if we need to, or if we want to, we can prove it. So this piece here is like saying log 5 over log b is equal to 6. And then here I have log 5 over log b to the 1/2, or you can leave it as a radical. So log 5, 1/2 log b. But if this is 1/2 in the denominator, it's really like 1 over 1/2, which is the same thing as multiplying by 2. So this is 2 times log 5 over log b, which we just said, this is 6. So 2 times 6 gives us 12. But if you know your shortcut, you have that to go off of. So this is using the change of base formula to help evaluate and manipulate log expressions.